Click the bell icon to get latest videos from Ekeeda.
Hello friends, today we will discuss about the concurrency control in distributed databases. We will first discuss today about the locking protocol and different type of locking like the single site locking, distributed site locking, majority locking, biased locking, primary copy of pages, and finally we will introduce what is the weakness degree of level consistency that we can control on this concurrent execution. Like the concurrency execution control we have done in normal database system, we will discuss today about the same protocols and how they can affect and change in this distributed database system. Now first, we have to know that if we are making a replica of copy in a distributed system, as if you can recall that the distributed system has many sites that is associated to it, and each site has got the database copy, which is called the local copy of that database. Now, if there are replicas to it, so the read operation is not a problem, but to write any operation on that particular data, we must update it to all the replicas to all the sites that they are belonging to. Now, all the protocols that we will follow now will follow this same rule. Now, first we will discuss about the locking protocol. Now to discuss the locking protocol, we must know that the locking coherency that we are having among two on these transactions or the distributed system sites, that which can be connected through a network and can give then shared and exclusive mode lock on this data item to read and write them and then write an item properly. Now the appropriate mode of lock should be chosen in this distributed system also, because other than that there will be an overhead of keeping the exclusive mode lock for both the read and write operations. Now first we will discuss about different types of locking protocol that can be an alternate, so that we can see that how we can improve in this distributed system. The first one is in single site locking protocol. The single site locking protocol adheres that for the distributed system, there is one system which we considered as SI. Now the system SI is given all the responsibility to choose among different types of locking and then allow to grant and release the locking on that particular site. Now the replicas that belong to site SI can also be granted on locks on any other sites. So now SI is the only one responsible for granting and releasing the locks. So as SI being the lock manager, it decides that when a request comes from other side about a lock on a data item, whether it is in SI or in their particular website, then they are allowed by this lock manager SI that the granting of lock or the rejection of lock. Now if they are not granting the lock, then there are two cases, that they are rejecting the lock or the lock manager requests the site to wait for the particular lock to be acquired, which is now acquired by another site. Now this type of single phase locking mechanism provides us with two simple advantages. First is the simple implementation, because only one site is having all the responsibilities, so there is no need to connect to different types of sites to have the permission or the replicas to get the locks permission. And the second one is simple deadlock handling. As if the deadlock will be occurred, it will occur only at one site, so it will be easier for us to handle the deadlock with all the primitive deadlock prevention, avoidance and handling algorithms. But there are advantages and as well as disadvantages to this simple phase locking mechanism. One is the bottleneck. First is that if the responsibility lies with SI only, then all the responsibility, all the granting and relocation requirements on this request on lock must be performed by the SY, creating a bottleneck to this SI. And finally, the vulnerability, because SI that only responsible, then if SI fails, then all the concurrency control execution will be lost and the manager will be lost, because SI being the lock manager only. Now there are two ways whether we can stop these transactions or the system. Otherwise we can be in backup side, two ways, and in recovery to this SI. Now in contrast, the second protocol that we will talk about is a distributed lock mechanism protocol. In a distributed lock mechanism protocol, there are a single site SI which we can grant and release lock, but associated with it there are many sites which can also grant and release lock based on the decision on a lock manager. Now it is not only the sole responsibility on this particular site SI. Now every site becomes their local administrator which can administer the locking system. That means locally on their replicas they can provide the read or write or the shared or exclusive mode lock to the processes that belongs to that site. Now it can happen that one process is requesting for the site's local permission for the locking, another process is having the same local lock that is being done on this other site. Now if it is the read one, then it is no problem that if you are having your local lock on the shared, that is been by on the shared lock manager. But what happens then one wants to write the data? Then even if the SIs are now belong to each only and the local manager can grant locks, if one replica is being written, I mean it wants to require and write operation to be performed on a replica, then all the replicas on other sites should be granted on the lock, otherwise we cannot write that replica anymore. So this is the main advantage of a distributed system, that it can use each of this system as a locking mechanism and each of them as a lock manager to themselves. But the disadvantage is that for the write operation inside these replicas, all need to be locked at the same time, otherwise the write cannot be performed, because otherwise there will be a cache coherency problem. Now the advantages of this one, that is the distributed lock manager, is simple implementation, because like the single resistance or the phase locking mechanism, it is also simple to implement because it only requires the architecture of that primitive site that is being attached to the network as a distributed system. There is no need to connect to other systems for the locking grantation of that particular site. But the disadvantage is, first one is the vulnerable to the write operation, because if one operation is being the write operation to one query to one site, then all the other sites must be aware of it. Other than that, there will be no granting of lock. But the deadlock handling is also a disadvantage to this distributed locking manager, because the deadlock now can be handled in many of the situations or like in many of the sites that can involve in this deadlock. The next type of mechanism that it uses is in primary copy. What do you mean by a primary copy? That all the replicas are given to this their own local copies to the sites that connected with distributed system. Now one of the replicas are chosen as the primary copy that is given at the site which is known as the primary site. Now the primary copy and the primary site is the site that is responsible for having the locks grantation on that basis. Now the shared lock can be granted by any other local lock manager to this site belonging to the distributed lock phase managing scheme, but the write operation must be granted an exclusive mode lock only in the primary copy by the primary site. Other than that, no one can write to their own local data. Now one variation to this primary copy is a majority copy protocol. In this majority copy protocol, if there are n different replicas of that particular database, then we need to have at least 1 to 1 by n, that is half of n number of copies on the replicas to grant it on this lock. So first we need to send request for the locks to half of these replicas that we considered the majority copy of these replicas. Now the request is delayed until the lock is granted by all the replicas that we have selected for the majority. Now after having permission, or after all the locks has been granted to their replicas locally, we can have the write operation access to that particular data. Now why it is better than this primary copy? Because now a majority of applications has provided the permission to write the data. That means the data written to this majority copy can be implemented in that way. And the second disadvantage of this type of majority copy is the deadlock handling. Again, as it is involving different sites as a distributed lock phase managing scheme, it will involve that some of the replicas, say suppose that one need one of them, another need another of them, both will have to occur for an starvation. Other than that, they will not get, and the request delayed will be there until and unless all the majority is being cleared. The second disadvantage is the implementation. That means to implement in that way, to do which half of the replicas we consider as the majority copy. Why should we choose that majority copy as this on half? So this one is an important decision that we have to make, and we need to include the primary sites that uses the query frequently as the majority copies. So this implementation becomes a little bit difficult for having this protocol. Now for this implementation, for requesting a lock, that we need 2 into n by 2 plus 1. That means a lot of number of messages to be passed to these sites or all of these major replicas. That means each of the replica will get 2 into n by 2 plus 1 number of messages, whereas to unrelease the lock, it will leak n by 2 plus 1 number of messages. Why the double needs for the locking? Because one is for this initiated site to the replicated site or the majority copy and then granted it back. But for the releasing, we'll need only one, because from this n by 2 plus the one site that is initiating. So for either the lock release or either the lock granting, we need half of them on the replicas to be granted on the lock. And for the deadlock handling, if we delete that, we need 3 of these replicas to be a majority copy. Now the transaction T1 is having the replica lock from R1 and R3, and transaction T2 has the lock granted from R2 and R4. Now if there are only 4 of these replicas present, and one having these 2, other having the other 2, both of the transactions are waiting for the third one that belong to the other one. So in this situation, the majority protocol goes in a deadlock handling, which is a very common scenario for this type of protocol. Now to remove this kind of problem, we will introduce the next section of the protocol. The next is the bias protocol. The bias protocol is a version of this majority protocol in that way that in bias protocol, if there is a query or a lock request for queue, then for the shared mode lock, we need all replicas in the majority copy to give at least one of them and grant on that particular lock. That means for the read operation, there is no boundary to it, but for the exclusive mode lock in the bias protocol, we need that all of the replicas in the majority protocol or majority copy needs to lock permit on that data. Now it is extremely advantageous for the read operation because it needs a lesser number of permission, thus the concurrency level grows. But if it is considered to be the write operation, the extra overhead becomes the problem or the disadvantage of this bias protocol. The next one is this queries consensus protocol. The queries consensus protocol is a generalization of this majority protocol, in which we can associate a non-negative weight with each site on this distributed system. Now there are 2 weights that we can associate. One is the queries read, another is the write queries. Now we can have, if S is the total weight that is associated within site, then we need to follow the rule that is QR plus QW, where QR is the read and QW as the write protocol. is greater than equals to S. That means the summation of our QR and QW of both this read quorum and write quorum must be greater than the S, that is total weight. Whereas the read queries and the write queries are the total number of read operation and write operation that is associated with each site. Now we can decide from this bias protocol that the site is more within read operation or within write operation, to which to decide that we go for an primary copy site or a majority copy site. Now another thing that we need to perform as this rule, that if we multiply that QW, that means twice the QW will be greater than also equals to S. That means if we consider that all the operations are right here, that means twice this QW will be greater than the total weight. Now we can say that the all read quorum that is associated with this protocol will have the utmost weight of R, and all the write protocol will have the utmost weight of W that is associated with this distributed system. Now the benefit of having this type of protocol is we can decide between the read and write operation, and according to this we can choose the read quorum and write quorum. If there are lesser number of reads, then we can have for the read a fewer number of locks, and if there are lesser number of writes, then we can have a fewer number of exclusive mode lock on it. And based on the weight, that is the total associated number of locks that we can grant on the site, we can decide that either to give it more to the locks on the read or more to the locks on the write. So in this way, these are the locking protocol that we have described in the distributed system as per the concurrency control onto the system. Next, we will discuss about the weak degree inconsistency while having the concurrency into the distributed system. Now many commercial databases forms on this replication, and there are many other forms that we can replicate with the data with weak degree level of consistency. The first and simpler type of replication is a master-slave replication scheme. In this master-slave replication scheme, there is a master site that is associated with each of this data, and now all the slave sites have their replications, but the master site being the primary copy of that particular data. So now when we are arriving to access and then provide the lock on this replication, then first we need to acquire the lock on the master site, and then the master site can decide that whether to give the lock permit to the shared site or the slave site so that it can write the data to their own replication. Now some of this application uses transient consistent snapshot. So what is the transient consistent snapshot? It is more like the transaction consistent snapshot. Like by providing the snapshot means their own set of data for each of the sites. Now the transaction consistent means if one transaction needs two of the sites data at the same time, then the transaction consistency defines that the transaction T1 and T2 cannot update the query on queue that is happening on the same both sites cannot be simultaneously performed. When we are having this type of problem in this master-slave relationship, then we can say that for primarily we are having the data onto the master side, and then the locking can be done with the slave side. Now the transaction that is making by this transaction on the master slide has been the primary copy on the transaction, and the transaction consistency need to be maintained so that one, the master slice first finishes its operation on the transaction, and the result of this operation can now be pipelined to the other transactions onto the slave sides. Now the database must be configured in that way in two of the approaches, that the propagate can immediately the update or they can delay propagate the update. That means at the master side all the updations is being made either on read or on write operation. Now the write updates are being propagated to the slave sites as a replication to the slave sites. Now the slave site can have their replication updated immediately when the master is being propagated the updation, otherwise overnight or every periodically. See, the master site is the one that is responsible for the updation, so it is not always necessary to have the replicated data immediately updated at the sites which is belonging to the slave site. Now the slave site can be periodically updated with the updation propagated to it. Now there is one more application that is concerned with this multi-master application. What is a multi-master application? That there is more than one master application or one master site that is considered as the primary copy. Now, what are the advantages of having a multi-master site is the main advantage of a distributed concurrency control mechanism. See, when we are having only one master site, then there is no question of concurrency because the slave sites are waiting for the update to get propagated. But when there is a multi-master site that is involved, now all the master sites are capable of updating their data concurrently with other master sites. Now we need to propagate one each other's update so that they can be aware of what update is happening on this other master site. Now the multi-master scheme uses two-phase commit protocol at most of its popularity because at both of these sites, say two master sites are involved in their application, so now both of they can commit each other transaction and now finally the transaction can be ended. Now other application uses a lazy propagation. Rather than updating it immediately, it goes for a lazy propagation that will update after a period of time even if both of the sites are the master sites. Now we use the lazy propagation is two different approach. The first approach apply the multi-master site, one master site being the primitive one. That means all requests are made to this one and then they will be propagated next to the other sites. And the other approach is all the master sites has been propagated at one time, that is one particular time. Every master site will be propagated their updates to each other. So in this way both are beneficial, but what disadvantage with the second approach is that once having the approach or the propagation on this update, then may have the master site has already updated the value. Say for the site SI or SJ, dual master sites that we are having, SI has updated the value on Q1 query, S2 has updated the value on Q2 query. Now the Q1 query is followed by this Q2 query in a transaction T1. So what is happening? The transaction is having Q1 after Q2, but as both of them are running parallelly and updated each other in concurrent execution, then it can happen that the updated result of Q1 is not received by Q2, which is one desirable. So the second approach of the lazy propagation may deal with this type of problem. Now some conflicts are there due to the lack of propagation or the lack of communication between the masters. See, even in a distributed system, if there is a network problem or the connection that which it's connect the databases from the replicas on the sites, is it having a problem, then the master sites cannot get propagated their update to all the replicas that is associated with it. Now the lazy propagation becomes an extremely useful when we are having the primary copy and the majority copy concept. Now the primary copy being the primary one to update these replicas, and all other replicas will eventually be updated sequentially. That means there will be a primitive order on which the replicas need to be followed out. Now these problems with an atomicity, that issue is solved, but the durability is not till now solved. Because this weak level of consistency that we are following in this master-slave relationship between the sites can lead us with the condition that the results that we are storing from one master site updation is not being the part of other master site updation, because at that point of time concurrently they are updating the same data. Now what happens that the disk on the replica copy of M1 and the replica copy of M2 are having two inconsistent result, which made the durability condition in false. So this is the problem of weak level of consistency on degree of an replication that we can have in the distributed system as part of the concurrent execution. Now all the locking protocol that we have described along with this replication problem can lead us the new issues that we need to solve, which we will describe in our next videos. Thank you for watching this video. Stay tuned with Ekeeda and subscribe to Ekeeda.